Sorry.
something
Yeah,
like
just
this.
change
Okay,
so
usually
from this side,
we're coming more
yeah,
from the live client perspective.
Yeah. Okay, sweet.
Which is
We're good. We're good enough.
something on top of
Otherwise,
it.
it would have glitched.
I'm trying to see
Okay.
how we can make it, because of course we have that set to see how live clients can pick up on that.
Cool. Are we ready to get started? Cool. So my name is Raul. I work at the EF. I am leading the peer-to-peer networking team. I joined 5 months ago, and I've been mostly focused on layer one. So it's kind of like I'm joining Lean these days and plugging into it with more attention. So I was kind of like figuring out how to best lead the session, given that I'm not like very much involved in the day-to-day. So I came up with this agenda of kind of like maybe these could be potential goals for this session, but it's entirely malleable. So like, let's figure it out here, what would be most useful to everybody in this room and in general for Lean and people who are outside this room as well. So I just like, let's use this as a starting point. I thought that I could share some context and insights on peer-to-peer from the L1 today, how it works and kind of like some of the learnings there to then influence, what we do in Lean. Ideally, I would like us to agree on peer-to-peer requirements for different DevNet stages. So if we can set a roadmap and kind of like figure out how the requirements are going to evolve and potentially how they're going to affect the design, that would be extremely helpful because that would give us a moving target that then peer-to-peer efforts can plug into to like change the design over time to cater to those requirements. So it can be versioned. So we can do a V0 and then like, this is deliberately something that is just a sketch and we can continue iterating on. I would like us to agree on design principles and the design space in general. So for example, some trade-offs in the L1 I mentioned earlier are that that there's no kind of like validator privacy by design, but also we're not leaking IP addresses or ports by design. So what do we want to do in Lean? Because we have very aggressive throughput requirements, which then could thwart or kind of like, close off a part of the design space. For example, mixed nets, onion routing, and so on might be out of the picture for Lean. I don't know. So just kind of like want to agree on some of those. And then we can just like go into discussing solutions and potential prototypes of like building blocks that we might want to prototype early to see how they would integrate into the peer-to-peer stack for Lean. How does that sound as a starting point? Sounds good? Yeah. Okay, sweet. By the way, I think we all, like most people in this room were in the previous session, so we kind of like already introduced ourselves, but I think we have 2 people here that weren't. I don't know if
I was. Yeah.
You were? Okay. Oh, you were? Okay, sorry. Maybe I was, sorry, I was hacking on the slides, so maybe I missed your address. Cool. So just wanted to give a little bit of an overview for a bird's eye view of L1 networking. We actually have 2 networking stacks running in parallel. There's the CL stack and there is the EL stack. So the CL stack is the libp2p stack that Lean is adopting by default right now. And libp2p has transport, handshake, and muxer modularity. We currently use 2 different kind of like compositions of this. So we use TCP, noise, and YAMX or MPLEX as one kind of like transport stack. And we use QUIC, which embeds a multiplexer and a handshake in it. And it's based on TLSB 1.3. Then we use Gossip Sub as the broadcast framework for all objects. And this is a massive problem. And we can go into that later. We use Discovery version 5 for UDP. This is interesting because it was a protocol developed kind of like in Dev P2P, which then still Dev P2P, which Discovery v4, and Guillaume can probably talk more about this, ended up ossifying so much in Dev P2P that we ended up implementing, like adopting it in the CL before the EL could. And this is, interestingly, this is UDP based. And this is at a point where the CL where QUIC itself did not implement or did not have support for datagrams. So it is kind of like one more parallel protocol that does not run on top of libp2p. It's just UDP based. And we have two domains. We have gossip and request response. The EL has dev P2P, which uses RLPX to handshake, authenticate, and to conduct multiplexing in a way, and uses this discovery v4 for, sorry, this v4 for discovery, which is also UDP based. So this is what the CL stack looks like today. It looks daunting, right? It's very complex. It's more complex than it should, probably, right? So this is one of the things that I think Lean can do, can leanify the stack, right? And this is something that we are also actively working on in the peer-to-peer networking team for the L1. So this is one of those cases where I think we can merge, like join forces to develop a leaner, more say, let's just say more modern stack that is Ethereum optimized, at least in kind of like the bottom layer of the stack, where then Lean can go and develop customized protocols for Lean, and the L1 can go and continue iterating on blobs, blocks, and other objects that we disseminate in the L1. So this is what it looks like. By the way, the things that are dotted are actually components available in libp2p that we don't use in Ethereum. And this is what takes me to the next, how we're planning to evolve the stack. So we're shooting towards, this is, by the way, you're getting very early alpha because I haven't talked about this publicly. So, so it's probably like there's going to be some Dev Connect announcements around this, just like, you know, this is very early, so it's probably going to change along the way. Please keep it like between us for now and people who are watching. But this is kind of like very early, right? The idea behind ETH P2P is that it would be the next generation Ethereum-specific networking stack, and I'll go into like what those building blocks are. And as an intermediate point, we're already working on Min P2P, a Go implementation of Min P2P. So this would be a libp2p compatible minimal networking stack that removes the pieces and the abstractions that we don't use from libp2p, and actually takes some more opinionated decisions while remaining libp2p compatible, right? So that's an intermediate step. You can think of it as like going from your perspective, going from a heavy stack into something minimal to then like slightly open up again into more specialized protocols. And the opening up actually happens by way of taking this component, which is Gossip Sub, which is a general purpose broadcast protocol, and actually starting to reason about dedicated broadcast protocols that are very aware of their slot timing, when it happens, of their required latencies, of the networking workload, right, that they're placing. So we start thinking about what is the optimal protocol for out-of-station broadcast. It looks nothing like the optimal protocol for blob broadcast. Right now, they're converging in both using Gossip Sub, and to add insult to injury, they're actually using the same parameters as well. So you're already seeing that there's a lot of inefficiencies in the peer-to-peer stack right now in the L1. Just by improving these things, we could actually make the L1 as well way more performant, right? Then there's things like traffic shaping and purposeful peering and potentially a built-in mixnet, which might be something we want to adopt for the L1. I don't know if it's viable for Lean, right? Cool. So I'll stop there because this is not a presentation. This is a workshop. So yeah, just kind of like, don't know, what do people think about this direction? Like, how do we think Lean could couple with this, leverage? Yeah.
Question, like, I still see like two transport.
Right.
TCP. What's the difference?
Cool. So in libp2p, we have this notion of transport modularity, where a a endpoint can actually, or node can actually expose any set of transports, and they're expressed by this standard called multi-adder, right? The reality, so this was actually a deliberate choice back when we adopted libp2p for ETH2, because back then we didn't know if light clients, like how light clients would operate with the network, interact with the network. So it was thought, well, at that time we wanted to have maximum flexibility. It is possible that light clients, and specifically Lodestar, was working, like one of the original visions was actually running a ETH2 beacon node inside the browser, right? So it was kind of like, part of that, like a browser interacting from the browser, and status as well. I don't know, Mami, I don't see Mami here. The status was also like targeting embedded devices, which is like another set of devices that also run, have other transport requirements, because there might be like in the wild, there might be like, it was this thought of like, hey, running devices in nature as well, right? And like these were legitimate use cases. So having the full transport modularity, where you also allow transports like WebRTC, WebSockets, and like the newer web transport and so on to actually be exposed as endpoints in the L1 network and the core network. That was a part of the design space that we wanted to reserve the right to, right? We did not use that. And like that is not the way that we would approach edge devices today, right? This is very inefficient to have a mobile device actually be an attestation propagator in the network. Like it's not a reliable device. It has very high latencies, and it's just not going to work, right? So today, if I were to like revisit that thinking, I would say keep the core network really tight, and then plan for edge layers that allow these larger variety of devices to participate efficiently without delegating trust. Like so, this layer has to be trustless. Right, so then backing out into how this part of the stack changes and evolves, now we think about two different transport profiles. So we have two substacks, right, that compose, okay, and sorry, just there's, libp2p also gives you muxer modularity and handshake modularity, right? Which, like, this has another set of problems that I won't go into. So what we're doing is like collapsing those choices into just two transports. The quick transport, which already comes with everything built in, and the legacy transport, which is, in some environments, UDP has problems. It's blocked, or like, you can't use it in the way you want it to. So that's why this looks like that. And then for ETH P2P, currently, so min P2P is going to support streams, but ETH P2P will support unreliable datagrams over quick as well, which gives us access to like another, opens up another set of like the design space as well for building protocols.
Okay.
Does that answer your question?
I have a few questions. The first one is conceptually, why is ETH P2P smaller than min P2P? Okay, I understand. It's a legacy thing that you want to be able to.
Yeah.
How do you see, and this is purely an L1 question, how do you see the transition happening? Because I don't know, I mean, when we met back in 2018, I was trying to get P2P to work with Get, and we had this prototype that worked. But really what forced Peter to say, drove Peter to say, no, let's not do that, is that he was saying, like, we're not going to be able to, if someone starts building on one network, putting a block, we need to make sure that this block is going to be broadcast on P2P, on dev P2P as well. It's a big mess. How do you see the introduction of min P2P / ETH P2P to that stack?
Yeah, so I see ETH P2P. I haven't discussed with Geth and other like team members about a potential unification. So I'm approaching this from more like the CL perspective. I think there's a lot that we can do to unify the tech stack, and I know that Felix and others are thinking along the lines of Quick as well. So we need to like actually, I haven't formulated this idea in a good enough proposal that I'm happy to present to them yet. But I do think that once we do, we probably have pretty good synergy there. And I think we would like maybe try to converge to the same tech stack, even though the network planes might still be separate, right? And in terms of a transition, that's where Min2P really comes in, because it's kind of like that transition vehicle for us, where we have a liB2B compatible stack, right? And then the idea, there's two different approaches here. We can keep this initially liB2B compatible as well, or just use a fork to transition over, really. There's a fork, like we can transition over definitely in the fork, or we can use like this negotiation as well that can happen there.
Oh, like that. Okay, because I was thinking like the fork, you can already have this in the sense that some people are going to agree later than others, and there's always a few people that forgot to agree to the client. But okay, that's their problem. But yeah, okay, so you would activate the switch at the moment of the fork.
So there have to be one version of the client, right, that would have both stacks, and because we're building this from scratch, we can like figure out a way that it's not obnoxious for that period, and then like that would be the transplant, right? We would transplant the network over to the new protocols, and then from the next version over, we would just kill the previous, just remove the code parts of the previous stack.
Right.
That would be like as I said, this is very early. I haven't thought about it, but that's kind of like some directional thinking.
Do you have any optimistic plan for in terms of timeline?
So I think Min2P is already starting to get worked on. We have one person actively like working on it right now, and a fraction of another person. So this is something that, and specifically we're doing it in Go because Prism is currently using Go liB2P, and Go liB2P is very heavy because it was actually, it's kind of like the reference implementation of liB2P, so it like ended up being the kitchen sink. And we just want to reduce a lot of that surface, right?
But do you build the Go Min2P library from scratch? Or?
Okay, I have a question. Please.
Right, I was just wanted to confirm. So, Quick is a relatively new transport,
right?
And it's gaining adoption. So, is there potential plans for deprecating completely TCP and YAMX and MPLX and noise? Like, for example, we recently built CLib P2P, and we were just reading discussions online that things like TCP, YAMX, they were considered baggage in the consensus there. And now that clients, like Rosslib P2P supports quick transport. I think Golang does as well. So should new implementations of libp2p deprecate TCP, because it will make the code base a lot more manageable if we just kept quick.
So I think I have to look at the latest stats from Cloudflare. By the way, if somebody can pull them up, Cloudflare has a really nice dashboard.
You mean about number of quick nodes or what?
No, so I'm looking at, if you can pull up the Cloudflare dashboard, global dashboard, that shows the amount of traffic, of internet traffic that runs on Quick. That would be really useful, because I think it's like still at a 33% or something like that. So, and it's kind of like plateaued for a little bit. And I think what's happening there is that there is significant ossification in the form of middle boxes that are assuming TCP and that are blocking like specific UDP patterns. And this is one of the problems that Quick is gonna face, and the group, the working group is actively working towards this. So I do think we still need to keep the TCP option, because UDP will not be universally supported on the same level as TCP. I think you're still gonna have to, you're still gonna encounter edge cases there. Now, the interesting bit here is that this should read TLS instead of noise. TLS 1.3, we already have a TLS handshake. And the interesting bit there is that we don't implement that stack does not consider MPLEX. You should just, if you're implementing from scratch, you should just do TCP, YAMX, and TLS 1.3, and then Quick. And then the interesting bit is that the Quick working group is actually working on QMUX, which is a version of the Quick multiplexer that can run on TCP. this is like blurring the lines a lot, right? And it's kind of like, wait, this is a multiplexer to like TCP, it's quick as UDP, like what the hell is going on here? But the conceptual idea is that you have a single API, right? That is a quick like API that deals with streams, and under the hood, it's using the UDP flavor, or it's using the QMUG, the TCP flavor with QMUGs. So it's a nice idea. And then like once that is available, there's a draft. Once that is like fully agreed on, we can replace YAMLs with QMUGs. But for now, I would not implement templates. I would implement YAMLs.
So yeah, I guess like I just had one more question.
No, please.
Yeah.
So basically, with this sort of stack, sorry, we basically have been relying on test plans, which is the libp2p.
Yeah.
So is this going to have its own interrupt test repo, or is the expectation that test plans or universal connectivity will be updated to support?
Yeah, the idea is that there's no support needed. There's just tests that you wouldn't run. But everything that runs that is compatible with MinP2P, or that is the profile, which like test plans is actually all of libp2p, right? So we really need to narrow test plans to what's applicable to Ethereum, and that should run on a MinP2P implementation. There's no protocol changes, right? This is libp2p compatible. It's entirely libp2p compatible. On the wire, it just looks like Go libp2p. It's just like a redesign for like dramatically less complexity.
So it's basically a new client and a new implementation of libp2p spec.
Yes, in a way, yes. Which is more like narrow.
Yeah.
Yeah, it's a profile of the libp2p spec. You can put it that way. What do you think?
We did the same with C++ libp2p.
Yeah.
Totally. I mean, we don't have even TCP because we don't need it weak.
Yeah.
And that simplified things a lot. I mean, we don't need users at all.
Yeah, exactly. Yeah, that's the notion. Yeah, but then for us, we're going to be using that to prototype ETH2P, right, as the reference implementation, and that's what's.
I guess like embedded ping, is that protocol different from the normal ping protocol that?
Yeah. So the idea is that you have. So if you use YAMLs and you use Quick already has native RTT measurements because they use for the pacing and for the window sizing, and YAMX already does RTT measurements as well. So why have another protocol? It's just leading up the stack. Okay.
Yeah. So I assume that for lean you would want something close to P2P, not the P2P.
Yeah.
Yeah.
Yeah, I think like in some cases yes, in others like I don't know this. I don't know what the latest blob stands on blobs is. What blocks actually look like it depends. But at least I would say the broadcast protocol would be a dedicated protocol for signatures, aggregations. Like there's maybe 3 protocols, right? There is the signature, emission protocol, then there is an aggregation protocol, and there's like the global aggregation protocol.
Right.
Yeah.
Okay, so that's fair. Thank you for clarifying this. So my question is purely in terms of, do we want that for DevNet 1, for example, which is if we want to do this, currently, I mean, in terms of the Z client, we are implementing everything, all of the P2P in Z. If we don't have to, that's even better.
Yep.
The question is, first, how much of what we did could be reused? Like, what components could be easily reused?
Yeah.
The first line. The second one is, could we have, this is a much lower amount of modules you have to implement, but it's still significant for something we want to do in December. So can we take a shortcut?
Yeah.
Maybe just create the specific signature aggregation and be done with it?
Yes. Yeah. I would do that. I would basically take kind of like your rewrite of SIG and think of just supporting these 2 transport stacks.
Right.
And then everything in between, like the machinery, if you're using Go libp2p as like your model, then like look at I wouldn't implement the network switch, or sorry, I can't remember, the swarm as it is today. I wouldn't implement the store, the peer store as it is today. Like, just rethink, the minimal, like what the minimal implementations could be.
Right.
So here we're thinking about a dialer and a listener. One problem of Go P2P, for example, is that it inverts the control. So it views the networking stack as like something autonomous that maybe the application like gets callbacks on, or it gets to plug into, but like in reality, the application should be in control of the networking stack. So that's what the new gen API is like, an API that gets control. So like just rethink it. And kind of like the thin layer that I think is the interoperability layer is pure IDs, multi-hash, and the transport choices. Everything about, and obviously the dissemination protocol, right? And kind of like the protocols built on it. Everything else is the guts of the implementation that you can like implement as you want.
Okay.
But we can discuss more about this. Like I can transfer some more like learnings that we've had and insights, so that we build a minimal necessary thing from the get-go.
Okay.
Yeah.
Just as we start implementing basically new P2P layer, how much, in your opinion, it makes sense maybe to implement it in a way how we implement cryptography today? So we have some single basic implementation, and then we have, I don't know, bindings, adapters that can actually reuse that, so that we basically have.
Yeah, so the thing about the networking layer is that if you have to cross an FFI like frequently, you're going to be leaking performance a lot. And then like if you integrate CGO, like if you're using CGO from Go, then like you become like single threaded, and like it has the serialization like problems. I don't think that's viable, honestly.
Okay.
Yeah, and especially like each programming language has a different set of like idiomatic
synchrony
principles of how you deal with I/O, how you deal with network, timeouts, like faults. So just building a single implementation is just gonna feel super unnatural when you adopt it as well. I think maybe you can reconcile that at the binding level, but it's still like gonna feel very clunky, I think. Yeah. Cool. We spent way more time on this than I wanted to. So I just wanted to kind of give a little bit more inspiration of what I see as like maybe a roadmap that would really help us. So if we place the different DevNet iterations in columns, and then like think about like all the parameters that define it, and some of these can be like fully constant, right, over time. If we just say, if we set on forced second slots, then that's it, and that's it. If we're going to be using 3SF finality, then that's it, and that's it, which I don't think it is. But then like also which environments we're targeting, and then like this allows us to like use this as a target to design against, right? And say, okay, now the broadcast protocol needs to change, then X needs to change, and so on. So just kind of like, as we think about DevNet, this would be tremendously useful. Cool. So now I have a laundry list of things here, which is kind of like, some collection of thoughts. And I just like want to stop there for a second. So this is not a monologue. Not supposed to be so. Is this being useful to people? Would we like to like go into protocol design, network design specifically for Lean? Or like some context setting is useful first?
I have a very stupid question. What are your main bottlenecks right now?
Right. Several. So right now we're making very poor use of available bandwidth.
Okay.
And this is for several reasons. So GossipSub produces a high number of duplicates, which is being improved over time with IDO1s and other mechanisms, right? Mostly IDO1s and like there's other ideas like choke, and there's other ideas about making some topics pull-based instead of push-based. Like there's a bunch of things there. But basically the idea is you have available bandwidth. Like conceptually speaking, you have available bandwidth. If you're not maxing out on bandwidth to support the throughput of the protocol, you're wasting resources. right? That's, well, I guess it depends on like, you know, if you speak to different operators, like the kinds of like bandwidth purchases that they make and like, you know, traffic egress, ingress traffic purchases that they make. But I would say from my perspective, if we're not using all available bandwidth, then we're wasting resources. So block propagation, for example, like in most cases, it will finish in 500 milliseconds. Now, builders and meth builders are using the rest of the time to actually continue playing timing games, right? Yeah. So some of them like will publish their block at second 3, knowing, and maybe they're hyper connected as well. So they like have a high guarantee because in the cost model, they can like very aggressively push egress and they can like on the first hop, they can maximally reach like a high number of nodes. So maybe they use that as a game to delay their block propagation, right? Attestation propagation is extremely wasteful right now. So I have a whole doc on this, we can go over it. But basically what's happening is that so the network is divided in 64 subnets, which correspond to committees. Every validator is assigned to one committee at every slot. Sorry, not at every slot, in the epoch. And that means that you're going to be having 500, around 500 in the validator like set today. You're going to be having 500 validators per committee. And in total, in every slot, you're going to be having 33,000 attestations circulating. So in every subnet, you expect 500. In the whole network, you expect 33,000. Every attestation is only 190 something bytes compressed with Snappy, right? And Gossip Sub we're using Gossip Sub. So we're reasoning about each attestation by hashing it, by trying to reduce duplicates, by like doing all this accounting of who sent me what and like who should I forward things to. And all of this traffic is arriving in a very pulsatile manner, right? Because it's arriving in 2 spikes. It's arriving, there's 2, so clients, beacon nodes. Some implementations attest to the first valid block that they see as soon as they see it. Others wait until second 4 to attest. So you see 2 spikes, right? And these are very pulsatile broadcasts because the tiny objects, they have to reach everybody in the subnet because you don't know who the aggregators are. Ideally, you would be able to have some directed broadcast where, you know, the aggregators, like you preferentially send to the aggregators, but that means knowing who they are. So it becomes, you know, de-anonymization vector. So basically, you have, like, for these pulsatile objects, you're doing duplicate accounting, you're doing scoring, you're doing all this thing for each one of them. You're doing hashing. So it's just easier to, and you know which ones you have to receive, like you know them ahead of time. So it's way easier to just send data around, except the duplicates in that case, maybe, right? And like we use prototyping and we're kind of like measuring things these days. But my guess is that we'll see a faster throughput in attestation. Now, all of this is reserved, like attestation, you have 4 seconds reserved for attestation. So like if currently it happens, I think attestation broadcast happens in like a second 0.2 or something like that. You can actually compress it further by optimizing everything that I'm saying. There's other inefficiencies, like topic names are represented as strings. So every attestation carries a topic name, which is like 47 bytes over 192. It's like 25% of the message already just for the topic. It's just like there's decisions that haven't been optimized that optimizing would like help a lot. And then on the third subslot, there is, which is aggregation time, there's just like way too much time spent there for something that is very light.
Okay, thank you. The reason I'm asking is because at least from the perspective of looking at how you can scale the TPS and sort of make everything reach performance levels that are really high. So I'm coming from theory, so some of my questions might be a little bit off. But, one of the first questions I would ask is that, you know, you have like the DA stuff, right?
Yeah.
You have the actual transaction sizes and that's really what informs throughput, and then sort of the ideal situation, the size of the pipes, the size of the bandwidth sort of is dictates the TPS. I'm just trying to understand, so after all the optimizations are pushed through, or if there's some sort of theoretical lower bound, like what percentage of the pipe or the bandwidth is taken up by non-transaction related information, like more consensus related, or like heartbeats, or I don't know what exactly goes in there, but like, do you have like a rough understanding, or at least some kind of like aim that you want to get to, where you would say that, like, I know you mentioned like 4 seconds initially for stations, like, how do you consider these things to split up? Like, because I agree with you that taking the full bandwidth is like super important. Like, what percentage of that goes to sort of bookkeeping, and how much of that really shows up in the TPS?
Yeah, right. So how much is good put, essentially?
Sorry?
Good put. And like in networking terms, we have this, like you have throughput, but you have good put, which is how much is actually dedicated to making progress, right? Yeah, exactly. So I would say like there's not so much control information generally flowing. It's actually useful information, useful data, except for the duplicates.
Okay, I see.
Yeah.
So that's a fundamental sort of issue that needs to be resolved.
That's a fundamental issue, but then then there is like the compute overhead as well of things that might throttle you at the networking layer. So if you spend too much time due to an implementation inefficiency, like processing a validation, there's like natural things that you can optimize in the logic of the application that then like also percolate back up to that. And there hasn't been a lot of attention in the CL to performance engineering. So like I think we can go a long way by investing time there and effort.
Sounds great.
Yeah.
Are any other teams sort of crack that issue? You guys can lift any code from anyone?
Which issue specifically?
I mean, the question of sort of optimizing the good foot, or sort of dealing with all this massive amount.
I think this goes into like, what the design space is. And yeah, we've looked into like, Solana, Monad, and others, and all of them. Like, I think the key element here is that you want to view the networking as a part of the protocol.
Yeah.
Right now we have this like duality where the networking stack is like this opaque thing that the protocol puts bytes on and expects to receive bytes from. And then you have the protocol, which is like autonomous as well, like attempting to put things. So if you design the networking stack with protocol, like with knowledge of the protocol, understanding of the pacing, which payloads are important at which point in time, what is the critical path, right? Then you can do things like traffic shaping. So you were talking about, for example, transaction, how much goes to transaction, how much goes to blobs, how much goes to blocks. The interesting thing is that we don't actually currently throttle or prioritize different classes of traffic. They're all competing at the same time. And what's even worse is that there's actually constraints. The constraints are set by EIB 7870, right, which Camille cited earlier today. And they represent both EL and CL, like as the totality. Now the EL is doing his thing and the CL is doing his thing, and they're both doing different, like they're both competing for the same bandwidth. So they're not synchronizing. Because the EL can, for example, throttle traffic while the block is still arriving, or while we're doing attestations. The CL could throttle traffic in other cases during like the rest of the slot, so that the EL has more time to propagate the mempool and the blob pool. Like the better mechanical sympathy is good.
I see.
Yeah.
That makes a lot of sense.
Yeah, so maybe some ideas here, just very quickly. Gossip stuff, no one size fits all. This is like a key learning, right? So we want to design the broadcast layer from first principles. We're starting to reason about specialized broadcast protocols for each like type of object. And in lean, this could mean signature dispatch protocol, a subnet aggregation protocol. If there are subnets, maybe there are no subnets. So therefore, maybe
This would be really great.
Yeah, so that's something we have to decide. A global aggregation protocol. So basically understanding the real, like the actual network load of each of these objects and optimizing them for bandwidth efficiency. So some ideas to consider as well, or some like directions. In terms of routing, are we a structured or unstructured routing? Do we attempt to be directed or undirected? Do we do subnetting? Do we incorporate latency as a primitive? Given that we now are measuring latency, maybe there's like an interesting protocol here that we can that we've been thinking about in the L1, and we still have to prototype. But a node could actually classify peers in different latency bands and then like specifically send to different regions, like with more awareness of where those peers are and what the latencies are. They could decide to like send to different layers so that messages start propagating regionally as well, like in different regions at the same, as soon as possible, right? Yeah, so revisit the bandwidth constraints, purposeful peering and scoring. This is actually very interesting because right now we have a peers that we're connected to, and then we try to score them in a linear way, and whatever it is, it is. Instead, what we're looking into is if we have a peer table that is segmented in 4 different purposes: block propagation, attestation propagation, blob propagation. We can then find the best peers in each of those categories instead of having all those use cases compete for the same share. So that's something that I would recommend we think about as well in Lean. How constrained devices are going to interact with the network. Are they going to be first-class citizens, or are they going to interact through an edge layer? Right? Like Justin mentioned that one of the North Stars is having mobile devices validate the network as well. How do we, a mobile device is intermittently connected, has high latency. You cannot rely on it for any dissemination. There's actually one of the problems that we have with the L1 today is if you start a node, anybody starts a node in their laptop, they will instantly be in service of the network, which is a problem because it gives you a lot of churn.
Yeah, I think there was a project, Portal Network, that was working on resolving that. But I guess with clients on the consensus layer front, mainly the reason, I'm not sure what the adoption today looks like, but mainly the big limitation for having browser support was that the clients themselves, they were on TCP. Browsers, they only support WebSockets. So it was very hard to get a browser extension running which could directly fetch the data from the P2P network. Mm-hmm. But if browser support is to be added, does that mean WebSocket becomes a additional component in that ETH P2P section or that Mint P2P section you showed, or does
it could be? I doubt it, because I think architecturally speaking, what makes most sense is actually having a specific edge layer such that those agents wouldn't connect to the core network, but they would actually connect to the edge layer, right? And that edge layer should be trustless, so very similar to Portal, maybe, right? At least in design principles. And then think about a mobile device should probably be receiving a request to sign a payload, to validate a proof, and to send an attestation, and then should be receiving the aggregate at the end. And those are the 2 interactions that you really care about if you're going to be having a browser extension or a mobile device, right? Yeah. So. But then there is also how are clients going to generally use the chain? How they're going to submit transactions? How they're going to follow the state, which I'm not sure exactly if this is the state at which those details are being worked out. Yeah. What do you guys think? Do you see these constrained devices as first-class participants of the network? Or?
First class, definitely not. I know the whole the whole like sales pitch is I want to validate on my watch, on my smartwatch.
Yeah.
That's probably gonna drive your smartwatch anyway. Yeah, I mean, I think that ties a lot into rainbow staking, right? I mean, it's maybe there's a rainbow staking, but there's also rainbow many things like rainbow participating. Do you want to be like your Raspberry Pi? Yes, maybe your Raspberry Pi can do some validation, but it cannot do RPC, like answer RPC, things like this. So I think like to address this specific problem of having the edge layer, you're gonna have to know what the whole zoo of actors on the network are gonna look like.
Yeah.
And I think this is way downstream of rainbow staking. So like of course that's a lot of awesome ideas. There are some like this one we can definitely not answer today.
Yeah.
But yeah, maybe. I also don't want to preempt the question if anybody else has something. But what I would like to have, and once again we can wait to address this, is if that were you, what would you like? How would you make it? Because unfortunately, I don't think any of us is a peer-to-peer expert except maybe Morgan and Camille. I can give you my generalist opinion as having developed execution clients for a long time. But honestly, I'll defer to you to tell us what you think, and then we can criticize because of this or that aspect. Criticize. Constructively, of course.
Yeah. That makes sense.
I mean, one addition maybe regarding the mobile devices, and Guillaume touched upon this already. I think the latest, or I think the broader consensus of mobile devices here is the power of a mobile device. So not necessarily like from like the processor of a smartwatch. And less sort of the Wi-Fi connection of a smartwatch. So that's probably the analogy here.
Yeah, I mean, I think like we should think about, are we really intent on like having like concretely these devices service the network, or is it more of a design principle that limited like constrained devices should be able to participate if they want to, but they're not gonna, like, we don't expect them to. Sometimes you do, like you set these goals to like design, to influence the design, but then like you maybe don't actually intend to, or you don't see that scenario panning out. I don't know. But yeah, I think this may be something we can defer to later. And yeah, like I can give an opinion once I have a better understanding of the protocol evolves, and like we're in a better place to actually think about this.
I mean, I can tell you one use case where you do want to have the edge layer. It's think of a dystopia. It's illegal to run the Ethereum network. You want to still be able to resist that censorship. You want to be able to hide those things. That means those nodes are going to be moving. They're going to be very light, very easy to conceal. Do we want that? Absolutely. Do we have to, do we have to fix it right now? I think there are more pressing. Thankfully, there are more pressing problems.
Urgent.
I also think that we shouldn't expect any battery-driven device to actually participate in the peer-to-peer network. That's probably not realistic.
Right.
I think one point you brought up, which was interesting, is sort of removing advantages of co-location due to peer-to-peer layer techniques. I think this is a topic which we will face in the future. And even as Guillaume said, like assuming like rainbow staking and sort of like admitting that it is okay for builders as an entity in the block value pipeline to be co-located. Like let's assume that sort of we get to rainbow staking. We like maybe there's interesting part we can discuss to allow for at least the attesters to be like have ways to communicate which allows them to be fairly or more widely geo-distributed than we have today.
Right.
And I'm not sure I understood the point you had about like certain latency assumptions, how a testers communicate could be sort of allow for like not putting them at a disadvantage if they are like widely geo-distributed.
Yeah.
So like an equal footing from like a networking, like latency perspective, even though they are widely distributed.
Right. I think this is a good segue into the next point, by the way. So one question is, Camille, are you taking notes or somebody taking notes? Or?
I thought it's recorded.
It's being recorded.
I'm open to would be good if someone had taken notes.
Yeah, sorry, I forgot to ask for it at the top of the session. But maybe you can spin up a doc and we can wait for like 3 minutes. You can share the link for people to like brain dump what we've heard so far to kind of like make up for this time. Does that make sense?
No, I don't understand.
Given that nobody has been note taking,
Yeah, but we recorded, right?
but wait, it's not super reliable, is it? Or
Yeah, it would be good to have both, actually. Like bullet point note taking and a record.
Okay, so let's do that. Camille, can you spin up a HackMD and just share the link in the Telegram channel for testnet, for DevNet?
Yeah, okay.
With the goal, so could you repeat?
And then we spend just like 3 minutes now typing up our notes from the session. Each person. So we crowdsource note taking and making up for the last hour. If you remember. If you don't, then that's fine.
I mean, that's the thing. Maybe what we should do is now try. Okay, I can put my computer in the Google, the thing, record everything that is being said.
Yeah.
So we record what's left.
Okay.
And then we do what you said.
Have that, right?
But I'm gonna have to reflect.
Okay.
I mean, I'm sure I can remember some things. It's just
Yeah, no, it's fine. Otherwise, I can kind of like I think I remember most of it, or at least the key points, and then we can complement it with notes.
What was the segue? Like what was
Yeah, so the segue is onto, okay, so right now the L1 is essentially a flat network. There is no sense of who's a validator and who isn't. Ideally, you would want a method to create a fast path. Camille has like mentioned those words, and I think they're right. You create a fast path amongst validators so that they can communicate. So they prioritize communication amongst them while still allowing others to participate and observe, right? So think about like read access and read write access to the gossip layer. And one potential primitive for that is proof of validator. So I just talked about this. I think all of you were here in the previous session. So that would be one way of actually creating kind of like an overlay and prioritizing traffic amongst validators, right? And that's why I said like it segues right into that point, because basically what you were saying is you have mobile devices or constrained devices that want to be first-class participants of the network in a way.
Maybe I'm thinking attack vectors here, because like if I have like fast path and sort of like these terms, they like in my mental model they are not necessarily good.
Yeah.
Because I don't know, we like what we want is like this the non-correlation of the attester. Let's say like assuming rainbow staking, we want non-correlated attesters.
Yeah.
And so if we correct me if I get the idea right here. If we had a privileged, quote unquote, privileged network of just
that's the key word. Not necessarily privileged in the sense that nobody else can join it or observe it, but you just know who of your peers are actually attesters or like have a role or are actual node validators. So you preferentially send to them. Right, and that allows specifically aggregators, right, to collect the payloads that they need to collect to run it through aggregation sooner than a random person running a laptop would receive it, because that's what you really want.
Okay.
So you want the critical path of the protocol, right, to run as efficiently as it can without de-anonymizing the role, ideally without de-anonymizing who's who.
With this, I'm just worried about like centralization of stake. Like if I have a lot of stake and now I'm sort of not privileged, but this like I have a better, like an even better view of the attested set.
Right.
So I have like, is there a way to like leverage economies of scale because of that? Then I would be like hesitant in sort of pushing forward, but
yeah. That's one of the difficulties of organizing something like this, where when you create the construct, like you could either, if you don't represent the balance or the stake, right, you could end up with a sibling out of this layer, because then I can like split my available balance across many validators and like, you know, flood the network. And if you represent it, then you have a de-anonymization vector. So it's like you want something in between. I think like on a conceptual level, it is basically like you want, I think I would vouch for something like this together with graceful degradation. So if you have a fast path, right, it just emerges on the network, but the network is able to operate without it, maybe at a reduced throughput. It's like baking in this principle, which is also like touches on, I think like some of the like doomsday scenarios that we do want to cater for as a design principle, because you want Ethereum to survive such a scenario, just lower. It's fine, maybe, right, for critical transactions, because it's not gonna. Yeah. So if you have compromised infrastructure, then you want it to continue operating, but it's fine for that period for it to have a hiccup in the sense that, you know, it is running slower. Yeah.
okay, sorry. Yeah, go ahead.
Yeah, so some more traffic shaping coupled to slot timing with back pressure. So back pressure on specific concepts, on specific objects. You want ideally like a self-organizing network with emergent roles. So there was some talk about what if we allocate GPU supernodes to perform the aggregation. Now, of course, if you identify them, some protocols can afford it because they have like this optimized infrastructure for those cases, and they have a permission network and everything, but we're assuming we don't, right? So ideally you would want like these roles to be kind of like self-emergent in the network, and for the network to continue operating without them as well, right? So is there a way in which you can measure the quality of service of nodes in the network locally, right? And just locally decide that you're going to send your signatures first to this node in your subnet, because consistently over time, it has appeared to aggregate faster, maybe. And therefore you think that, you know, they have a higher, they have higher chances of including your signature, and therefore you send. So it's kind of like, you know, you let the structure emerge versus like creating it top down. Yeah, so I already mentioned the next point, which is getting rid of the networking versus consensus duality. What I tend to call it is like aiming for zero idle time in terms of resources. So you maximize available resource utilization. I think we kind of like touched on this and agreed. Yeah, something that we learned is like really actually specifically spending time optimizing peer-to-peer networking stacks is valuable, because otherwise we see a specific performance and we assume like it's rate limited by design and not by implementation. So now we're actually spending a lot of time looking into profiling implementations, and we're actually discovering several bottlenecks there, not necessarily in the peer-to-peer networking stack, but also in the clients. So we don't want to be in this place where we just take implementation hotspots to be protocol design flaws. And then, yeah, just what do we want to do with like our essential principles, right? So do we want to have some form of embedded validator privacy? Can we have mixed nets? Can we have onion routing? Can we have like some of these methods, comma, dangling comma for like other methods? What do we do in terms of censorship resistance, right? Like these are things that I think we should be thinking about as well. Which, like, you know, are usually at the other end of the trade-off spectrum, which is the problem, right? Because now if you want to introduce onion routing, well, you're introducing extra hops, right? So now you're introducing latency, and therefore that penalizes the overall throughput of the protocol, unless you find a way of like doing maybe delayed execution of some kind, where you give things more space to like, I don't know, to become what's the pipelining there, right? Where you can make this work, maybe. I don't know.
Yeah, the only problem with this delayed execution is that if you give more slack, people are going to start using it.
Yeah.
And you're going to have to find more time
later. It's a losing game, right?
Yeah.
Losing battle, yeah. Well, so that's kind of like, I think everything that I had today, it was a lot. So this. Oh, back pressure is the notion that if your application is slower, then your producer, you rate limit your producer as well. So you're kind of like filling up a queue up until a point where you can't take any more, and at that point, the other party knows that you're in that stage, right? And they stop sending and they stop dropping messages, and they start dropping messages, right? So the idea there is, for example, we're prioritizing right now signature propagation, for example. Then we might want to, like, that will, if we have limited bandwidth and we have like too many signatures to propagate, that's going to naturally back pressure everything else, right? But you can only achieve that like application level back pressuring by actually designing for it in your protocol, because you need to structure your protocol in that way. So for example, gossip stuff today would not be a good example because all topics are flowing through the same streams. But if you had different streams for different purposes, then with Quick would like use up the entire window when there is back pressure, and the producer would know.
Yeah, so if I remember correctly, we have dedicated session for metrics tomorrow.
Mm-hmm.
And so do you have any advices for bootstrapping these metrics regarding P2P?
Oh yeah, a lot. Yeah, a lot. Yeah, there's like a lot of metrics there that you want them at a lower level networking stack, like kernel metrics in terms of. You want to have congestion control metrics, you want to have like connectivity metrics and other things. You bandwidth utilization per like peer as well. Then you want to have like the actual networking stack metrics. So what transports you're using, what is your churn rate, what is the size of your peer table, like all these things. And then you want to have like metrics for the protocols themselves. So if you're using attestation, like if you're using broadcast protocols, then like metrics for those, duplicate rate. You want to have like messages, peers per group, and then you want to have application level ones. So yeah, it's different layers there.
Sorry, just rebounding on what you said.
Yeah.
Do you know how to collect those metrics from a regular like Linux machine?
Yeah, there's a few libraries, and like if you look at net data, for example, which is actually a full web app, right? That does like the whole. If you look at what it does under the hood, that would be a good thing. Another good starting place would be the Prometheus exporter, the node exporter, which exports system stats as well. I don't know if it goes to a peer level, but I've seen like there's libraries in most programming languages that already do.
I mean, the peer level is at the app level, we
Yeah.
can export this. It's just,
Yeah.
you know, I mean, I used to do a lot of external development.
Yeah.
I never looked at the network side of it, so that's where I'm curious.
I think you collect them through Netlink, through the Netlink interface.
Okay.
I think you have a bunch of messages that you can send through that socket to collect stats.
Okay.
Yeah.
Understood.
Because you don't want to go the eBPF way, because that would.
That's true, you can do that, yes.
You can. You can. Yeah.
Yeah, okay.
Yeah.
So out of like these ideas, like is there a way to group them into like in terms of client implementation, like a base, like minimum design that you want to test out?
Yeah. We can with your help. We're a small team in the EF, so like we don't want to centralize this design. Like my goal here is not to tell you what I would like to do myself or my team. It's more like transfer the knowledge so that we can self-organize as a community to actually put together a spec that learns from the past and kind of like aligns with the direction of the L1 as well, so that we can like work together.
Yeah, I mean, given Guillaume's idea from earlier, like, since we have you as an expert.
Yeah.
And what we can say is sort of we, at this stage at least, let's say we care about like 2, 3, 4 things.
Yeah.
Let's say, for example, sticking to EIP 7880. So let's say Nielsen's law may not apply to the globe equally. So we will always have like whatever certain regions which will be stuck at 50.
Yeah.
So. And with that in mind, and sort of with the goal, and then assuming sort of the rainbow staking, so we make what we care about is like the geo-diversified tester set. Maybe that's another thing we, from a networking perspective, can also like prioritize. What we can add is maybe validator privacy is good, but maybe not a must. So if we like have like 3, 4, 5, 6 assumptions.
Yeah.
And we'll say, okay, this would be really cool to at least start with, quote unquote. Like, how would you start? Or where would you say, okay, guys, look at it. Let's start with this.
Yeah. I think what I would do is I would take and structure probably kind of like a spec with a lot of gaps that we should with options right inside each of those gaps. So we know, for example, just to give a very clear example, with signature propagation, right? We have a very ample design space, which includes subnets, maybe not. There's a structured topologies. There's the grid topology. There is gossip sub. Like we know gossip sub is probably not the thing to use. So like that would be, I think I can inform like different directions that I would like us to explore basically in each of these areas. And then we can work together and create a set of projects, right? To go and prototype those directions in a more comprehensive way.
I think
would that help? Yeah.
I think what we could also do is like headliners, like hard forks, where we come up with like some simple headliners where what we want to achieve with this networking design, and then group all those like features that we want to try out.
I was thinking like if we want to place them in a sequence specifically, like having something like this would be really useful. Because like ultimately we want to prioritize depending on what each DevNet wants to shoot for. But yeah, I'm totally happy, like, helping structure all of this, honestly.
Yeah, so for the DevNet too, we already need to have aggregation, so we should have some at least direction, like what we should be able to implement.
Yeah.
As I presented, just having gossip sub, I'm afraid might not be enough if we target like 8K, 16K validators.
If DevNet 2 is going to be the first DevNet that's gonna have that's gonna test out the mechanics of aggregation.
Yes.
I would keep it really simple from a networking perspective. Just do the dumb thing from a networking perspective, because what you want to test there is that aggregation works, and you want to get an understanding of the performance profile before you go and like optimize the network for it, right? Because you probably want to like you're gonna have many rounds of compute optimization of aggregation, right? Until you get to like something that is
the
like
simplest thing would be just rely still on gossip itself, just re-implement what we have for BLS aggregation.
Yeah.
Kind of the same type of the subnets. Maybe maybe not at the scale that Justin and everyone talks, not 8K nodes, but maybe, I don't know, maybe 1,000 with each committee or each subnet of maybe 128 validators, something like that. That could be just one thing if we just want to test aggregation. And then, we kind of get the numbers like, I don't know, how long it takes to aggregate. Maybe for the DevNet 3, then target some fast path priority, fast path topologies, I don't know.
So two questions here. What are we doing for telemetry? Or is this the subject of tomorrow? Because as we test things out, we want to capture telemetry of every single node to like roll up to a dashboard and understand how things are performing in the wild. And like it could be totally fine. For now, I would say, if you actually have a top-down, if we have a top-down network in the sense that there's no P2P per se that could be rate limiting. I think we're at this stage, maybe we're at the discovery of how fast like we can go in terms of if you remove the network from the picture, like a peer-to-peer network, and you just have normal one-hop networking, imagine, right? And you have like a centralization there. So say, for example, I have a 1,000 node network, right? And I want to test out what a optimal subnet design would be like if we have 16 subnets. Then a node would connect to like a server that would place it in a subnet and would just like do a mesh without gossips up, or like it would maybe like even like centralize through a server. I don't know, like I think I want to first like understand how fast these protocols can go. These implementations can go of the crypto side of things, because that's going to ultimately determine like it's also going to determine like what the network
we have
constraints
numbers like 1,000 signatures per second and 10 starts per second, so that's the compute target that we want to have.
Yeah, but we don't know over time like how that is going to be achieved, right? And in each DevNet.
Yeah.
So,
I don't know, it's just a wild idea out there.
So that means we would be downstream, like this decision would come downstream of actually knowing like the crypto. So that means for DevNet 1 we would be doing like signature aggregation, except we were talking about using BLS instead of this whatever number of XMMS or XMMS. XMSS. But okay, so that what I mean is we're starting to see a tree of dependencies of what we have to figure out that I'm afraid has some loops. We're gonna have to break that somehow.
I was thinking, this is just like, we're just brainstorming, right? So because I don't want to feel like I'm giving any instructions here, but like my thought here is I would really like to have a baseline of what is like with a 1 million node network, or like whatever we're shooting for ultimately. If I have the central coordinator that just simulates different topologies, then I can like try out every epoch or every like day, I can try out different formulas of organizing that network without actually having to like implement something and roll it out, and like the feedback loop becomes way shorter. And then once we manage to organize nodes in a specific way, we can then figure out potentially how we can, like how the peer-to-peer equivalent of that organization would work, and B, like how much we're willing to compromise and leave on the table to like get the peer-to-peer to actually transition to peer-to-peer. Right. So we have a good baseline. We know like bare metal, like fast, like, you know, the baseline, like, you know, remove the network overhead out of the picture. Then we simulate network overheads by dispatching and like introducing latencies and so on in a command and control way. And then we actually, with all that data, we actually go and figure things out. Because otherwise, I think we're just like trying out things and shooting in the dark a little bit, and the feedback loop would be maybe like too long.
So how do we build a simulator? Can we reuse what you guys have done? Or?
Yes.
Yeah.
I mean, yeah. And what you said that we're trying things. This is where, again, coming back to structured topologies, they could be really helpful. I mean, for them, it's much easier to predict like how many hops we have. We cannot say this about gossip stuff, for example. So some parts, yeah, we can predict pretty accurately. Some parts we need to simulate before we actually understand.
Yeah.
So yeah, we still need simulators.
Okay, so maybe because we're reaching we're at time.
Do you think that like this in the wild actual like command and control kind of like way of organizing the network would be useful? Or do you think that with a simulator only, like we have good enough data?
Yeah, could you repeat like?
Yeah, so essentially we're trying to like get to an understanding of what network organization would be best, right?
Yes.
So is a simulator enough, or like actually seeing it in the wild and literally organizing the network differently every day because we have a command and control way of doing it would be
simulator is faster. I mean, the only thing is it's hard to verify like how accurate it is, and we're also taking some shortcuts in simulator to actually make it run faster. It's very resource consuming to simulate large networks.
Yeah.
So for example, when we simulate, for example, we couldn't simulate Quick. It was just too slow because we integrated Quick into NS3, but it was doing all these cryptography operations which we actually did need for our performance metrics. We assume they're usually very fast. There are some shortcuts. There ideally it would be like we have this simulator like we wrote. Then we have clients. Then we have ideally they are compatible with Shadow, so we can test different assumptions with different networking bandwidth, latencies, all of that.
Yeah.
And after that, we're actually confident. We know like how network behaves under different conditions.
Yeah.
And then we can test it out. In some real environments.
Yeah. Shadow is great, but it's difficult to run and like a resource.
Which is why we start with first simpler simulators like ours consumes less resource.
Yeah. So this thing that you said about structured, I think this is a very important decision to make in terms of structured topologies or not.
It's not like structure or not. It's like whether we can integrate them as a fast path, maybe, or in addition to existing topologies.
The thing is that with a structured topology, you would specifically designate, like you would need to know, like it would need to know the endpoints of the peer. So this like puts us like this.
We should
undermines validator.
We should always make an assumption that whoever has their address exposed, they might be under attack, they might not be accessible. So which is why they only, but still, in most cases, in optimistic scenario, they should work. But we should work also without them somehow.
Yeah. This is something that the L1 has been avoiding for a long time.
Yes.
So I don't think that like it's I wouldn't be comfortable making that compromise for you.
Yeah, it's something that, I just don't know how to achieve these aggregation targets faster. I mean, we have 4 seconds, we have 3 kilobyte signatures.
Is there a way that we can find, like we can construct a structured topology just by, I think by observing and deciding. So gossip sub in reality is kind of semi-structured. It is not unstructured. in the sense that it does have a scoring algorithm that prioritizes latency as one of the the parameters. So it ends up, in theory, it can end up constructing a latency optimized mesh if you configure it right. But not consistently, because with Gossip's Hub you have every slot has a different producer.
You only give scores to your neighbors.
Yeah, but exactly, and then you evaluate other neighbors as well as you connect to them. So you're using, like as you connect to them, you're incorporating them in your non-mesh, so in your full mesh, and I think you can promote them, right, to replace another peer if you're hearing IHAVs from them before you're actually receiving messages from your peers.
I mean, okay. Yeah, that's the proper process of it.
Yeah, so it's a little bit kind of like this adaptive, kind of like epi-sub, sort of like.
You can give scoring in structured topologies as well. Easily, I mean, we see that. Who is following the rules? If we have, for example, read, who is sending messages faster?
Yeah. Because for the L1, we're actually the direction that we're really keen on right now is erasure-coded broadcast, but it does not apply to.
But it's for blocks, probably.
Exactly, it does not apply to many like simultaneous producers.
It might be doesn't make to apply it for global snark aggregation, which has size of 128 kilobytes.
Yeah.
Yeah. So this is where we might actually take advantage.
Yeah. Yes. Absolutely.
Yeah. Because for now it's distribute. That's another question which we didn't explore yet.
For that, we can actually go the Solana style and actually split up the payload into MTU-sized chunks.
Yeah.
And then distribute them over UDP. So it's very fast.
Let's try this in one of the devnets. I mean, we can so basically we have player one as testing this encoding stuff, which we never did.
This is the fastest. Like, I tell you, like this is going to be the fastest.
Yeah. So great. Let's introduce this to DevNet.
But global aggregation is like redoublifying, isn't it?
I mean, no, because it's not necessarily global aggregation. It's just once we have some aggregation, it has size to 128 kilobytes.
Okay, got it. Right.
Even if we have just a single subnet, we need to distribute the final snark to everyone.
Yep.
So to do that test in the DevNet, would we need the actual signature thing for at least the size?
No, we would need just some data of size 128 kilobytes to test this, or even larger size.
Okay. So we could take just a BLS signature to test the aggregation.
We can just take. I proposed this on one of the calls. Just message. Trust me, I collected enough signatures. I'm good. I'm okay, and fill the remaining part with 0, so that make it 128 kilobytes.
Right.
I'm not sure whether we really need to complicate things with BLS, to be honest.
Happy not to.
Yeah, it's just we need to. If we want to test P2P layer, we just need the size of the message, particular size of this message.
So could we say, because that's the question we're trying to answer, could we say DevNet 1 is going to be exactly about this, so that we collect exactly the data that we want, and we can move on. We can make a decision during the debrief of DevNet 1. So we fill this column somewhere. I don't know which one that corresponds to, maybe slot time.
Yeah. So for the DevNet 0, for example, we don't really have the signature size of 3 kilobytes. So maybe for DevNet 1 we can target this, and then we can collect the necessary data, like how long it takes to, whether we can, for example, collect enough signatures to do fast confirms for the 3SF stuff.
So then you don't actually have the aggregation itself, but you have something simulating it, and it's deterministic, so you can verify that each validator is able to decode.
Right.
Yeah.
And then we can move to the next slide. DevNet 2 and make them faster, actually collect data.
Yeah.
That would be awesome. So I think the other thing is we're at time, and I'm hungry. Yeah, I would like to say, I would still love you to describe your ideal thing.
Yeah.
Because we're going to reconvene tomorrow, and we decided we would do some coding and stuff like this.
Yeah.
We can also take the time to to collect. Like do this actually. By the way, my recording has failed, so we're still gonna have to go through the HackMD and everybody has their stuff.
Yeah.
That's okay. We can do that.
Yeah.
And then tomorrow we reconvene and say, you try to send out your ideal thing, and tomorrow we reconvene and we say, okay, we want that, we don't want that, like just to have a baseline so that we can discuss.
Yeah, I would really want to have understanding for the DevNet too, like we have some kind of aggregation, how we actually do this. I mean,
Sorry,
I'm trying. I still don't have that understanding. So for the DevNet one, we do aggregation just for a single subnet. Is it correct or?
So that's the thing. Like they were saying earlier, someone told me earlier today, we're not gonna have. Realistically, if you want to do aggregations, they don't know how long it's gonna take.
Yeah, I mean, let's keep let's avoid cryptography. Just some dump aggregation with some mock data.
Okay, fair.
Yeah, can we do this for the DevNet one, or?
Yeah.
And then for DevNet 2, my understanding was that we actually gonna start implementing the subnets, things like that. But for that, we need to have, if this is correct, we have to understand like what topology we should have and all of that. But that it's still not clear for me.
I would say, yeah, we're not gonna decide today probably what DevNet 2 would look like. But I think if we have an agreement that on the networking side, DevNet 1 looks exactly like that, like this, like 120 kilobyte messages.
Yeah.
Some kind of trust me bro approach, it doesn't matter at the moment because we won't have the crypto. We just get rid of BLS and that's fine. And then on the what's that called? We still have to decide what DevNet 1 is going to look like in terms of other things like what payload do we put in the blocks? Like, I'm sure there's more stuff we can put that is not network related. But I think if we zoom in into the network aspect and we already decide this is what we want, so we can implement this. This stuff.
Yeah. So. Okay. So for example, great. Maybe have DevNet 1 with some dump data. Should we experiment with this encoding stuff for DevNet 1?
Right, exactly. That's what I was going to say. Sorry, I just wanted to ask, in that, is P2P thing, could we have a minimal subset of things we could implement that would be ready for DevNet 1 that would still let us, stuff we know is most likely going to be there in the final product, even if it's not the whole stack?
Yeah. So we want a spec. Minimal spec would be ideal, right?
Yeah.
Of erasure coded broadcast that we can implement with synthetic, like random payloads.
Yeah.
Deterministic random payloads.
Right.
Deterministic random. we all understand.
Yeah.
DevNet for DevNet 1.
Exactly.
Right. Yep. Is it fine? Like, are we okay just not using libp2p for this specific test?
Yes.
I would be really.
I mean, we still use libp2p, but just to connect to peer and send message. Or what? Or how you?
No, I would just use Quick. Do we all have a Quick library available?
Yes.
Yes.
That's good.
Okay.
That way we get like the closest baseline to what the protocol would be without involving libp2p or the networking, like a specific networking.
Can't we just? Sorry.
Well, I was just questioning. If we're not going to use libp2p but use Quick, we'll still have peer IDs and multi-addresses and.
Yeah. So that's the idea. So we'll be adopting like. Maybe what we can do is adopt a quick transport from libp2p that does the handshake in the form that libp2p does it today with a peer ID. So we'll still be having this. But then we can just consume the quick transport directly instead of like having to go through the abstractions of libp2p.
Which abstractions? Because I think Quick handles most of the abstractions. We don't have YAMLs there.
Exactly, that's what I mean. So we don't use the lippy2p abstractions. We just go to Quick directly, but we use the lippy2p handshake for Quick, which uses the TLS 1.3, the ALPN from lippy2p and everything, and authenticates the public key against the peer ID. Does that make sense?
Okay, I was not implementing Quick myself, so I might be using something, but it's like, it sounds to me like Quick, even if it's part of the lippy2p, it's already good enough, so we can use it. I mean, we just to open a stream to some peer using Quick, but over lippy2p, not avoiding it. It doesn't make much difference using it as part of lippy2p or without lippy2p, but with lippy2p it would be a bit simpler because we already have the integration with lippy2p.
Yeah, so we use lippy2p.
I mean, every client here has their, I mean, for DevNet 0 we target to use only Quick. So, and we already use Quick transport.
Okay, that's good then.
Yeah.
Yeah, I just didn't know if you were like doing the whole spiel with lippy2p. Okay, if we just use the Quick.
We only using Quick, we don't have like,
so we use lippy2p.
Yes.
And we build a custom protocol that is no gossip
Yes.
that does the erasure coded broadcast.
Yeah, fine.
Yep.
So we are targeting for DevNet 1 for the custom networking stack.
Not necessarily custom, but on top of the lippy2p streams, for example, stream protocol. It's going to be some stream open.
Yeah, lippy2p streams.
Yes.
So I would say for now, Lean should continue using lippy2p. Just don't build a lot on it right now because we are evolving the networking stack, and like lippy2p is going to be there in mainnet for at least a year, right? So it's not going away. Like we shouldn't move away from it in Lean, and it's also like we want to make sure that like we explain why, like we put the right messaging out and everything in terms of Ethereum as a community understands why we're like changing our networking stack in the future when it comes to that. So we don't want to like jump the gun. So let's just continue using lippy2p, but just the bare bones of lippy2p, which is quick, with its like with the streams, and that's it basically.
Okay. I think there's a timeline question as well, whether like implementing the P2 plus the networking changes, how would that affect the timeline, whether that's actually...
What is the timeline for DevNet 1?
Well, from original discussion, we hope to do it before DevConnect.
Yes, so in a month.
So,
is it feasible to do? I mean,
I know it looks good to do it before DevConnect, but if we actually do something of value and we miss the DevConnect deadline by 2 weeks, I don't care. See what I mean? I mean, I'm sure Justin and Ladislas might not like it so much, but as far as I'm concerned, I'd rather bring stuff.
We can do this as part of DevNet 2 if, I mean, for example, if erasure coding part would slow us down.
Yeah.
But do we have lots of tasks remaining in the pq integration? So there's a library provided. So.
Yeah. My main concern is like this is good to do because it fills another part of the stack. But for me, the biggest unknown is the first part, which is the actual signature dispatch and the initial aggregation to the initial aggregator. That's like one unknown, but I think that's going to deserve a lot more, like a lot more research.
Okay, so just to recap, and so that we have we use lippy2p as is today, even with our Rust implementation, which I'd love to delete simply because it's for an extra file. But okay, we do this, but then we add a new protocol on top of it, which I guess we could reuse if, worst case, we reuse it from Rust if we don't have a better interface with our stuff. I don't know. Did you, how, I know it's mostly Kai working on it these days, but do you think it would be possible, easy to do, at least in Zig?
I think we have most of the quick stuff already. It's just that we don't have the lippy2p abstractions on top of it.
So that would save some time.
Yeah.
Okay.
Yeah. So we said this is for DevNet 1, and for DevNet 2, we want to start using real aggregates. Is that the idea?
would be as I saw this on DevNet 2, we actually want to start experimenting with the subnets so that we also have local aggregation and global aggregation. Maybe it's too challenging to finish before I don't know what was the target, end of the year or.
DevNet 2 would be before the end of the year. Does anybody know? Like,
I would say yes.
Or it's okay, it's up to us.
okay, well, it can be completely. It doesn't have to be the crypto. Like, we're depending on whatever happens in the other room in terms of crypto and how fast they can deliver. So all that matters is that the subnets are.
I mean, once they figure out the crypto, provide us with bindings.
Yeah.
And if we tested everything else, then we're good. We should check.
Right.
Like P2P layers works correctly. We have interop. We have. Replacing stuff with crypto stuff shouldn't be.
Yeah,
hard after that.
If they don't have the crypto already, we can still do something meaningful on DevNet 2.
Yeah.
Okay, fine.
Okay, so I think my main takeaway here, and by the way, let me just off this part of the discussion, I just got this in. I posted the HackMD link in the Telegram group and in the DevNet channel. So please go ahead. I've left room for you to copy and just to put in your name and dump your notes. So let's all take maybe 5 minutes to do this to make sure that we captured like the most important bits of the conversation.
Could you copy your slides as well so that to help?
Let me just
jog memory.
So this is the HackMD. Yeah, I see that people are on it already.
Should we wrap up the sort of official session in here? Or anything? Or
just give us 5 minutes to like finish dumping our thoughts in the doc, and then I think we're done. Yeah.
Oh, okay. And just in terms of like the recording. Or is this now the async part of the? Probably.
I think what we can do is, if people have time, because we're over time already, right?
We are over time, and we need to go to the at least punting starts at 5:30.
What is punting?
Punting on the cam to dinner.
A small block.
Yeah. It's to the problem thing.
No, like you.
It's like Venice, but better.
Anyway, I think we can finish the session for now, and then sort of just dump the notes, and then continue.
Sure. So, but then we have to meet